In this video, we're going to step back and take a look at typical packages that microprocessors come in and before we get into more details of how the hardware and the software gets connected and what those different pins mean and how do you configure them. So this device actually it comes in three different packages that are shown here. There's the DIP package, there is the SSOP package, and there's the QFN package. But before we go too far into this, let's go ahead and take a look at a little more detailed description of these packages, just in case you're interested or you ever have to make a decision between them. So this package is called the DIP package, dual inline, or PDIP to be exact, standing for plastic dual inline package. This is what we use in the labs typically for prototyping and learning because it's really easy. They push right into the proto boards and we can make connection to them and modify them really easily. So that's a favorite for using that, and most of you have probably used this before. There's a little dimple up here which indicates which side is the top of the chip, and usually there's a little circle right above pin 1, and the count goes from pin 1 to pin 9 in this case, and then 10 all the way up to 18. Data sheet has all this information, so if you get interested or if you want to learn more about it, all the location and sizes and the tolerances and all that is indicated here. You notice it's so precise that even it talks about how far bent out the pins are when they come in, and then how far you can bend them in. For humans, that's not a big deal. For machine, this is a big thing because the machine puts pressure on those pins, and those pins are sprung out, so they put pressure back. That's how it holds the pin to put it in. And the disadvantage for this is when it comes to manufacturing, this requires that you make holes, or vias, what they call them, vias, which is really holes, plated holes through the board so the pins can go through them. And most manufacturing processes, we don't do that because then it would require a technique called wave soldering, which is relatively expensive to do. Almost exclusive nowadays, unless there is a good reason for physical strains or something else we need to have a through hole, most manufacturing these days do what is called surface mount. And this package is another package that's available, that PICmicro is available in, and this package comes in a surface mount. In other words, you notice that this is curved, so it would sit on the board, and there's no holes in the board, there's no fancy soldering going on. You put a solder on your connections to the board, put this one on it, and literally blow hot air on top of them, enough of a hot air such that the solder melts, and that's that. So this is a favorite. It's easy to do, relatively quick, and again, all the data you need about the sizes and all that is provided here. And this is probably the smallest package they would have, as the name implies, is the plastic shrinked small outline package, and that's just another way you can get. There's a QFN. I didn't see the QFN in here shown. Oh, here it is. Here's the QFN, and I'll take that back. This is probably the most likely one because if you notice, the pins are even underneath, so they don't take any room at all. So you can build lots of stuff in a small area. So that's probably by far QFNs are the most common packaging for these devices when it comes to manufacturing, large quantity manufacturing. Okay, so that's good enough. Now let's go back and talk about what those different pins will do and what they mean. So if you go back here, we've talked about, actually one of the pins wasn't there, but one of the packages is not here. But anyway, these are different packages that are provided, and we talked about the one we're going to focus on specifically is the one we're going to use in lab. The pin numbers are the same, and they're configured pretty close to each other. So let's go ahead and use this package and let's talk about a couple of things that are really important for you to be aware of. One has to do with this pin, okay? Pin 5 is really, really important for you that pin 5 be connected to ground, okay? And then pin 14, right across from it, is the power pin. This device is capable of running anywhere from 2 volts to 5.5 volt. In this class, we're going to run most things in 5.5 because the rest of our circuitry requires 5.5 or 5 to run. So we're going to run this one as 5 volts. Okay. All right. So that's really the big thing when it comes to this. The other thing you might notice really is that every pin has got a lot of names associated with it. You see how many multiple different kind of names associated with it. So so for example, one of the ones that has the most number of names attached to it is here. And if I were to spell out what all these things are, for example, RB6, that's the digital I/O. So you can configure it to be a digital I/O, meaning either accept ones and zeros and read them in, or write 5 high and low outside so you control something else. It is used for programmer. If you take a look at your PIC2 or whatever you're using to program the chip, you will see that they're using, so it's used for programming the chip. It also can be used for timer 1 oscillator in case you want an external oscillator for your timers. But we'll talk about timers in the future. It could also be used for other timer like timer 3, external clock. It could be used for pulse width modulation. That's a way of controlling the speed of motors. Could be used as one of the pulse width modulations coming out. It could be used to interrupt in case the time changes, and again that we'll talk about later. So this name is interrupt on change. Okay. Now the question you may have is, how do I know which one of these are using? So what controls all of this is in the special function register grouping. You can go in there and make changes, and those changes will determine which pin does what. And what we're going to do as a strategy, rather than trying to throw all of that in one video, which is next to impossible to do that, what we're going to do is, as we go through and we discuss a certain function, we're also going to introduce specifically how these configurations will be changed to make that happen. Now, if you haven't done that, it's really a good idea to go ahead and write down someplace or make copies of the instruction sets, make copies of just a summary of instruction sets, summary of the SFRs, because it's really nice to have that quick reference to deal with it. And they're available all in the appendix of the text. Okay, so now we learned that, and as a matter of fact, what we're going to do, the next video is going to start talking about I/O. How do you use this chip as a device that can put information out and read information in on the pins? So we're going to come back and deal with I/O. As we're dealing with I/O, we're going to learn how to set a special function register and move forward. That brings us to the end of this discussion. This video was intended to give you a perspective of the different packages that are available, and also the fact that each one of these 18 pins have many functions, and it's really important to understand that you have to configure the chip in order to know what the pins are doing. And as I mentioned, for the very first time, for the first thing we're going to do is we're going to configure this simply as an input-output, digital input and output device, and see how we will go about doing that. Finally, really important, this doesn't change regardless of what your configuration is. It's really important that you make sure that you don't mix pin 5 and 14. Pin 5 is grounded, and pin 14 goes to your power. Now, you could choose to run this thing from 2 to 5.5 volts. We're gonna try to run it at 5 volts in this class for this video and all the experiments we're doing here.